Okay, we're on to the next group of problems. So let's start at problem number 15. Determine the most probable next term in each of the following lists of numbers. So we'll start off with 15. And the numbers are 6, 9, 12, 15, 18. So what is the next most probable number? That's very similar to the problem we just did, problem number 11. The first thing you usually do is look to see if you've got a common difference between the terms. When you have that situation, you have what's called an arithmetic sequence. And so what we see there's 3 different between each consecutive term. So we would assume that the next term in the sequence would be 21. Okay, let's look at 19. So we have 3, 6, 9, 15, 24, 39. Okay, so you start out and you think, oh, it's similar to what we had here, this difference of 3, but all of a sudden it's not anymore. So the first thing we do is we look at it and see what the differences are between the two. There's 2 cases. We have the arithmetic sequence, which is a common number between the terms. And then you have a geometric sequence where there's this common ratio. So, you could look at the ratio of these 2 numbers, but you kind of look at it and you see 6 divided by 3 is 2, 9 divided by 6 is 1.5, 9 divided by 15 is some strange fraction. So it's not going to be a geometric sequence. So let's look at the differences. So we have 3. So 6 minus 3 is 3, 9 minus 6 is 3, 5 minus 9 is 6, 24 minus 15 is 9, 39 minus 24 is 15. So that's that one. And if you read the book, and we probably talked about this in class, I'm actually doing the homework first. The next thing you do is you actually look at the difference between these numbers. So the difference between 3 and 3 is 0. The difference between 6 and 3 is 3. The difference between 9 and 6 is 3. The difference between 15 and 9 is 6. And so you're starting to see a pattern. 0, 3, 3, 6. And next, let's think about this. So if we go one more level, we're going to have 3, 0, 3. Okay, sorry for the break right now. It's the week before classes, so I'm trying to get a little ahead. Anyway, I realized that the thing I was showing you is actually from the next section. So one thing, let's go one level here. So if you take 6 minus 3 is 3, 9 minus 6 is 3, 15 minus 9 is 6, 24 minus 15 is 9, 39 minus 24 is 15. So actually what I saw was if you take this difference and you look at the difference, you'll see that this plus that equals that, this plus that equals that, this plus that equals that, that plus that equals. So we induce that the next number would be 15 plus 9 is 24. And therefore, the next number here is going to be 39 plus 24, which is 63. Okay, so that's how that one works. A little more trickier. Okay, let's go to 23. So we have 1, 8, 27, 64, 125. So let's look at these things. Now, if you looked at the difference between these, you'd have 8 minus 1 is 7, 27 minus 8 is 19. 64 minus 27 is 37. 125 minus 64 is, better make sure I'm doing this right, get my calculator out. 64 minus 27 is 37. Okay, 125 minus 64 is 61. And I really don't see anything happening there. Let's look at it from the geometric standpoint. You know, are these any of these numbers squared? Is 8 something squared? Well, yeah, it is, but it's a fraction, so it's a decimal. So how about cubed? And that's kind of what I saw, was I saw the cube thing. So 8, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So what we see if we rewrite this is we have 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. Cube means multiply the number by itself twice. So this is 1 times 1 times 1, 2 times 2 times 2, 2 times 2 is 4, 2 times 4 is 8, etc. So by induction, we would assume the next term is going to be 6 cubed, which is 6 times 6 times 6. And if you take a calculator, you get 216. So the next number, this would be what we would use, and we'd use inductive reasoning to figure that out. Okay, what else we got next here? 27. So we have 5, 3, 5, 5, 3, 5, 5, 5, 3, 5, 5, 5, 5. Okay, so 5, 5, 5, 5, 3. So what we're seeing here is just the numbers 5 and 3. So we go 5 to 3. Then we have 5, 5, 3. So we have 2 5s in the 3. Then we have 5, 5, 5, 3. 3 5s in the 3. Then we have 5, 5, 5. I think 5, 3. So there are 4 5s in the 3. So we're seeing this pattern of 5. You can come up with some mathematical way of representing it, but it's 5 and 3 is alternating, but the number of 5s keeps increasing. So what we would expect is that the next one will be 5, 5, 5, 5, 5, 3. Because we have 1, 2 5s, 3 5s, 4 5s. And we expect 5 5s. And in this case, they just asked what the next term would be, and the next term would be 5. But that's how it would continue. And the next one would be 5, 5, 5, 5, 5, 5, and then 3. Okay. And let's look at, okay, so I think that's all for right now.